Okay, this is a local area network with the following network address, and just notice this, that the host bits are set to 0, right? And that is exactly what we said. We said that if all the host bits are set to 0, right? Remember, in a class C network we have 8 host bits, right? So if all the host bits are set to 0, then this becomes the network address. All the host bits have been set to 0, so this would equal what? This would equal 212.36.77.0, right? So this has been converted into 0. So when all host bits are set to 0, this is the network address. That is why any station within this network, any computer within this network, cannot be assigned the IP address 212.36.77.0, because this IP address belongs to the whole network. So this IP address belongs to the whole network, therefore it cannot be assigned to an individual computer within the network. So it cannot be assigned to an individual computer within the network. And now, so if computer A wants to send a message to computer B on this local area network, what is it going to do? It is going to create a packet, and in that packet it's going to attach the IP address of computer B, right? And it's also going to attach the IP address of computer A, right? And that's how. So this message is now going to travel from this computer. It's going to go to this switch. This is a switch. This is used to connect the computers together, and from here it will be passed on to computer B. Okay, and no other computer on this network will be able to receive this message. This message was sent from A. It will go through the switch only to B and to no other computer. But what if A wants to send a message that A wants to send to all the computers on the network? So A wants to send this message, and it wants that this message should be received by every computer on the network. So this message should be received by B. It should also be received by B, by C, by D. So in this case, if A wants a message that all the other computers on the network must receive, then A must use a broadcast IP address as destination IP address. Then A must use a broadcast IP address as a destination IP address. For broadcast, all the host bits in the IP address must be set to 1. As we know that this is a class C IP address, therefore we have 8 host bits. We have 8 host bits, and all of these must be set to 1. So when we convert these last 8 bits into denary form, then this becomes equals to 255. So our broadcast IP address for this network is 212.36.77.255. If a message is sent where this IP address is in the destination field, then that message will be received by every computer on this local area network. So this packet, or this message that has been prepared, this packet is going to be sent by computer A, and it is going to be received by every other computer on the network, because this is a broadcast. This is a special address where all the host bits have been set to 1. So this is going to be received by every computer on the network. So now we know that in a class C network with 8 host bits, when we can have 256 addresses, we in fact subtract 2 from those 256 addresses to get 254 host addresses, because all zeros in the host bits are used for the network address and all ones in the host bits are used for the broadcast address. So let us repeat the same exercise for a class B IP address. In a class B IP address, the prefix is 10, the network bits are 14, so these 2 bits plus these 14 bits is basically equal to 16 bits. So the first 16 bits are going to be used for the network, and the remaining 16 bits are going to be used for the host bits. Let's take a look at this IP address. This is class B IP address because this number 165 is between the range 128 to 191. So anything between this range in the first octet, if it's a value between 128 and 191, then this is going to be a class B IP address. So the question that we're going to answer is, what is going to be the network address when we have this from this IP address? What is the network address that we can determine, and what is the broadcast address for this network? Because we know that the first 16 bits in a class B IP address represent the network, then this is going to be our network address, right? And our broadcast address is going to be all ones in the host bits, right? So we are going to say 165.219.255.255. So all host bits, when they are set to 1, this equals 255 and this also equals 255, right? So this is going to be the broadcast IP address for a class B network when we have this IP address, right? So from this IP address we have extracted these two network addresses and broadcast addresses. So a message sent to this address, if this is going to be the destination IP address, then that message will be received by every computer on the network. So because this is a broadcast destination IP address, right, all host bits have been set to 1, therefore this message is going to be received by every computer on the network. Let's repeat the same exercise for a class A IP address. In a class A IP address, we have a single bit used as a prefix. So this single bit plus these 7 bits is going to be 8 bits altogether. So we're going to use 8 bits for the network address, and the remaining 24 bits are going to be used for the host address. With 24 bits, it is possible to have 16 million different hosts. Okay, so you can have 16 million different computers, 16 million computers with different IP addresses, unique IP addresses on a single class A network. You can have these many hosts. Okay, let's take a look at an example now. Okay, let's solve this example. This is a class A IP address because the number that the starting number is 31, right? And if it's a number between 1 to 126, then we call this a class A IP address, right? So this is a class A IP address. In a class A IP address, only the first 8 bits are reserved for the network. So the network address in this case is going to be 31, and all the host bits are going to be set to 0. So .0, .0, .0. And the broadcast address in this case means that all the host bits must be set to 1. As you can see in this IP address, you can see that only one of these octets, only this final octet, has all host bits set to 1. So this is not a broadcast IP address. Remember, all the host bits, all of these 24 host bits must be set to 1, right? So don't get confused simply because there is a single octet with a value 255. All the host bits must be set to 1. Therefore, the broadcast address in this case is going to be 31.255.255.255, right? So all the octets that belong to the host bits, all of them have been set to all ones, right? So all host bits must be set to 1. So this is the broadcast address.